Okay guys, my name is Mrs. Hine, and today we're going to be talking about single replacement reactions. For this lesson, you are going to need page 14 in your packet. It looks like this. Page 15 in your packet looks like this. And then you're going to want a periodic table that either has the charges of the ions and the polyatomic ions, or whatever it was that Miss Voorhies gave to you when you were talking about ionic compounds. Now, for my students, I gave them this periodic table with ions, and I gave them this list of polyatomic ions. So I left this with your sub. He has copies, so if you need these, you can get them from your sub. Okay, so before Miss Voorhies left, in your last class, you were doing a lab where you were looking at single replacement reactions. And what you were doing is you were taking a single piece of a metal and you were adding some sort of solution where an ionic compound was dissolved in water. In some reactions, you saw a change. Some, nothing happened. Today we're going to talk about why some single replacement reactions occur and why some don't, and how we predict the products of the single replacement reactions when they happen. So on page 14, you have what's called an activity series, okay? So on the left of the arrow, you've got metals. If I've got an element that is a metal, he is going to kick out another metal from the compound, okay? If I have something that is a non-metal, he's going to kick out the non-metal from the compound. Now, when I look at this list, the arrow tells me that I've got decreasing activity as I go down. What that means is elements on top are more reactive, which means they are able to kick out any element below them. So for example, lithium is my most reactive metal. If he runs into a compound with any of these other metals, he's going to kick them out and take their place. Potassium is still very reactive. He can kick out any of these metals, but he cannot kick out lithium, okay? Over here, non-metals work the same way. Fluorine is my most reactive non-metal. Most reactive non-metal. He can kick out chlorine, bromine, or iodine. Chlorine can kick out bromine or iodine, but not fluorine. Now there's one weird little exception on this list. If you look, even though hydrogen is a metal, he will behave as a non-metal when we're looking at single replacement reactions. Sorry, let me rephrase that. Even though hydrogen is a non-metal, he will behave as a metal in single replacement reactions, which is why he's on the left side of that column. However, when hydrogen gets kicked out, hydrogen as an element does not look like a regular H. Hydrogen as an element is always H2. He's diatomic, just like my other nonmetals, so they will never exist by themselves. Okay, so let's take a look at how this would work. On page 15, I've got a list of reactions. So in my first reaction, lead is the element. So if I look at my list, I know that lead is a metal, so he's going to be kicking out another metal. The other metal in this equation is zinc. So lead is going to try to kick out zinc and take his place. Now if I look at my activity series, lead is here, zinc is all the way over here. Zinc is way more reactive than lead. So lead can try his hardest, but he is not able to do this. What's going to happen when I mix these two things? Absolutely nothing. I have no reaction. Okay? Let's take a look at iron and aluminum. Again, iron is a metal, so he's going to try to kick out aluminum, which is also a metal. Because iron is lower than aluminum, is he able to kick him out? No. Aluminum is more reactive, so because he's higher, nothing happens. Okay? Let's look at number 3. Number 3, I have Ag. Whoops, it's going to be Ag, but in this case, I've got Ca by himself. He is my element. Sometimes your element by themselves will be your first reactant. Sometimes the element by himself will be your second reactant. Because calcium is a metal, he is going to try to kick out silver. So let's look at our activity series. Calcium's here. Silver is all the way down here. Calcium is way more reactive than silver. So what happens? Calcium kicks out silver, and silver goes all by himself as an element. When calcium kicks out silver, he's going to take his place. So calcium was by himself. Now he's going to partner up with Br. When this happens, it is going to form an ionic compound. So I have to make sure that I'm balancing charges. If I look at my periodic table, calcium has a charge of +2. Bromine has a charge of -1. When my charges don't match, I switch them. So this one comes across over here. This 2 comes across over here. So I'm going to make CaBr2. Now in this reaction, because they're switching partners, because they have different charges sometimes, I need to check my reaction and make sure everybody's still happy and balanced. So I started with 1 Ag on the left. I have 1 Ag on the right. I started with 1 Br on the left, but now I've got 2 on the right. So I need to fix this Br. So I come back over here and I multiply by 2. But that 2 doesn't just fix my Br. He's also going to change my Ag. So now I have 2 Ags over here. So I need to come back to this side and multiply by 2. Okay? So when we do single replacement reactions, I always use little numbers, subscripts, in the back first to make sure that my charge is balanced. After I balance my charges, I use big numbers, coefficients in front to make sure that my equation is balanced. Okay? Let's take a look at number 4. Okay? In this case, the element by himself is iodine. Iodine, oops, wrong paper, sorry. Iodine is a non-metal, which means he wants to kick out another non-metal, fluorine, chlorine, or bromine. So he's gonna come over here, he's gonna try to kick out bromine. Non-metals work exactly the way metals did. So I look at my list, iodine's here, he's trying to kick out bromine. Can iodine kick out bromine? No, absolutely not. I can only kick out something if it is below me on the activity series. So when it is lower than the one he's trying to kick out, okay, doesn't matter if we've got a metal or a non-metal. If the element is lower than the one it's trying to kick out, no reaction. If the element is higher than the one it's trying to kick out, then we see a change. Okay? Let's take a look at problem number 5. In this case, the element by itself is chlorine. Chlorine, if I look at my list, is a non-metal. He's trying to kick out another non-metal. So I've got chlorine trying to kick out bromine. Chlorine is higher than bromine, so this reaction happens. Bromine is going to get kicked out by himself. Now be careful. All of your non-metals look like hydrogen. F2, Cl2, Br2, I2. When they are in elemental form, they are diatomic. So even though bromine gets kicked out, he has to be Br2. Okay? Now, chlorine's going to take his spot. So he's going to partner up with aluminum. Aluminum, if I look at my periodic table, has a +3 charge, whereas chlorine only has a -1. Now be careful. The one area that everybody makes mistakes, they try to write this as Cl2. Cl2 is my element. Cl is my ion. He can be by himself as an ion. The only things that will keep their little numbers are polyatomic ions. Things like nitrate, things like sulfate, they can keep their little numbers. But if it is not a polyatomic ion that you learned, it does not keep its little number. Okay? So Al is a +3, Cl is a -1. When charges don't match, I flip them. So I'm going to have Al1, Cl, this 3 comes across, so 3. Okay? Little numbers are for charges, big numbers balance the equation. So I started with 1 Al over here, I ended with 1 Al over here. I started with 3 Brs over here, but now I've got 2. 3s and 2s, the only way I can balance them is by turning them both into 6. So 3 times 2 is 6. 2 times 3 is 6. So now my Brs are fixed. However, when I put this 2 in front of my Br, I also changed Al. So I need to put a 2 in front of Al. Okay? Well, this 2 fixes the Al, but it also changes the Cl. I had 3 Cls. I'm multiplying that by 2, so now I have 6. Over here, I had 2 Cls. I want 6, so I need to multiply it by 3. Okay? Pause this video for a second. Try number 6 on your own. So what you should have seen in number 6, Br is the element by himself. Br is a nonmetal. So if I look at my list, Br is going to try to kick out one of these. So he's going to try to kick out I. Because Br is higher than I, he's able to kick him out. We should see a reaction. Remember, when I gets kicked out though, he is not just I, he is I too. Br is going to take his place, so he's going to partner with sodium. Again, I look at my periodic table. Sodium is a +1. He's partnering with Br, not Br2. It would only be Br2 if it was a polyatomic ion. Bromine has a -1. +1, -1. My charges are the same, so I'm going to take them, push them together, and make NaBr. I need to check and make sure that my charges are, that everything's balanced. Started with 1 sodium, ended with 1 sodium. Started with 1 iodine, ended with 2. So I need to multiply this I by 2. That fixes sodium, or sorry, that fixes iodine, but it also changes sodium. So I need to come over here and I need to multiply that sodium by 2. Okay? When I look at this 2 fixed sodium, but he also changed Br. I had 1, now I have 2. If I look at the left, I originally had 2 Brs, so now everything's balanced and good. Okay? So try the remainder of these problems on your own. Be careful when you are looking at problem 7. Remember that H, when he gets kicked out, is H2. Down at the bottom, when you're looking here, even though this product is technically, or this reactant is technically watered, think of it as an H and an OH ion. So your metal is going to try to kick out H. When you're done, the sub has an answer key. Show the sub your paper to get your sticker and check your answers.